Hello everyone and welcome back to The Explainer. Today we're jumping straight into a breakthrough that honestly sounds like pure science fiction, but it's rapidly becoming a grounded scientific reality. We are looking squarely at the intersection of artificial intelligence and one of the absolute deepest mysteries of human existence, sleep. For centuries, our dreams have been totally locked away, completely private inside our own heads. But thanks to some truly massive leaps in generative AI and advanced neuroimaging, the boundaries of what is actually possible are shifting right before our eyes. So today, we're going to explore whether these latest tech advancements are literally on the verge of decoding the secrets of our sleeping minds.
Okay, let's dive into this. It's kind of the ultimate sci-fi fantasy question, isn't it? What if an artificial intelligence could literally tap into your brainwaves while you sleep? Just picture it, glowing digital waves around a sleeping brain. A person drifts off, and instead of those wild landscapes and bizarre scenarios staying entirely private, an AI is right there, quietly reading those neurochemical pulses. What if a computer could actually translate those electrical signals and understand the very emotions and images you're experiencing while completely unconscious? It's staggering to think about, and it's no longer just some hypothetical movie plot. It's the exact question driving some of today's most cutting-edge neuroscience research.
Section 1. Decoding Brain Activity, the Laboratory Reality. And this brilliantly illustrates how this whole thing actually works in practice. The mechanical process researchers use to explore these complex signals is absolutely fascinating. It's basically a giant puzzle that we can break down into 3 core steps. Step 1 involves carefully monitoring brain activity while a subject is asleep. But scientists aren't just looking at basic surface-level brain waves. They're usually using functional MRI or fMRI machines. These massive scanners measure tiny changes in blood flow right in the visual cortex, tracking exactly which parts of the brain light up during specific sleep phases. Then, Step 2 brings the AI into the equation. The raw data coming out of an fMRI is incredibly dense, so an AI system, typically a highly sophisticated neural network, is tasked with analyzing these complex signals, sifting through all that biological noise to find meaningful data points. Finally, in Step 3, the AI tries to identify specific patterns in that neural activity that are directly linked to certain images or experiences. The AI is essentially cross-referencing the sleeper's brain activity against massive data sets of waking brain activity, basically hunting for a digital fingerprint for the things you see in your mind's eye.
Section 2. The Current Reality, Tempering Expectations.
Now, what's really interesting about this slide is the stark contrast it shows. We naturally want to picture this technology acting like a DVR for our dreams, right? Like a system that captures a crisp, high-definition movie that we can just play back on our TV the next morning. But reality check, the scientific reality is vastly different. Today's technology absolutely cannot do that. What it can do is make highly limited interpretations, and this only happens within incredibly controlled research settings. You literally have to be lying perfectly still inside a massive, noisy fMRI tube in a lab covered in sensors for the AI to even attempt to make sense of the data. So yeah, it's a far cry from slipping on a sleek, wearable headband that seamlessly records your dreams while you snooze in your own bed.
So, if it's not a crystal clear movie, what does the AI actually spit out right now? Well, based on those complex blood flow signals, the computer currently generates, scratch that, it doesn't generate a clear picture at all. It produces what can really only be described as blurry, messy, dreamlike images. Think about why this happens for a second. The AI is essentially trying to paint a picture from a highly complex, secondhand description. Researchers are actually using generative AI models similar to things like Stable Diffusion. But instead of typing in a nice, clear text prompt like a dog in a park, they're feeding the model raw brainwave data as the prompt. Because the brain's visual representations are just so abstract and fluid when we're asleep, the resulting output is fuzzy and highly limited. It's essentially the AI's best guess of what the brain might be visualizing. It's an absolutely brilliant technical achievement for sure, but it remains incredibly raw.
Let's move to and see how this builds into Section 3, the future of dreams. Just imagine a research subject finally waking up, stepping out of the scanner as all those futuristic graphics fade away. So, what comes next for this field once they're looking at those blurry AI-generated images of their own mind? Well, this quote directly from the source material really captures the true spirit of this work. As neuroscience and AI continue to advance, scientists hope to learn more about how the human brain creates dreams. You see, the ultimate goal of this research isn't surveillance or mind reading just for the sake of it. No way. The real objective is unlocking the fundamental mysteries of the human mind. Scientists want to use AI as a vital tool to understand the very mechanics of human consciousness. And the practical value here is immense. Cracking the code of how we dream could unlock revolutionary new ways to treat severe sleep disorders, help us understand exactly how our brains process trauma, and show us precisely how we consolidate our daily memories. It's a real game changer.
So the crucial point is that we are standing at the very beginning of a long, incredibly complex scientific journey. We've seen how researchers map the visual cortex, we understand why the current visual outputs are just blurry approximations, and we know the intense limitations of needing massive, highly controlled laboratory setups. But the trajectory? It is crystal clear. Artificial intelligence neural networks are only getting smarter, and our neuroimaging tools are becoming more precise by the day. We are steadily moving closer to demystifying the deepest, most private functions of the human brain.
A huge thank you to our source for today's information, Future Tech Insider. We are left looking at a horizon that literally pushes the boundaries of neuroscience and technology. So, I want to leave you with this final, provocative thought. As this incredible technology inevitably evolves over the coming decades, do you think artificial intelligence will ever truly be able to understand, or perhaps even experience, our dreams? Keep wondering. Be sure to follow Future Tech Insider for more amazing future tech stories, and I will see you on the next explainer.